Hello everyone, welcome to our channel Physi Dive. I'm this your teacher Alexi Rajan. Today I'm here with a new topic of class 10 NCERT, that is atmospheric refraction. So there are three subtopics in this particular topic, that is the twinkling of stars, as well as what is the apparent position of stars, as well as we'll study very important subtopic, that is early sunrise and delayed sunset, or otherwise advanced sunlight or delayed sunset. So without wasting time, let us dive in straight to the class. So to the class. So here comes our first topic, that is atmospheric refraction. So we'll study about what are the reasons for this atmospheric refraction, and also what are the different subtopics coming under this atmospheric refraction. Otherwise, we can say what are the different phenomena that are coming under atmospheric refraction. So first of all, we'll see what are the phenomena that are coming under the atmospheric refraction. First one is twinkling of stars. Second topic is apparent position of stars. And the third topic is that early sunrise and delayed sunset. We'll see one by one in the coming session. What is the main reason for this particular atmospheric refraction? This is what we have to study first. Earth's atmosphere is completely filled with different particles, small particles, dust particles, water droplets, and different things. Okay, as a result, our atmosphere is continuously changing. So here you can see that the temperature is also continuously changing according to different layers. So temperature is also changing. As a result, different layers are different. Different layers have different optical densities. So this is the reason behind the changing atmosphere. Different layers have different optical densities means what? The refraction takes place at different levels. Okay, so if this is my atmosphere like this, okay, and it is of different layers, and let this layer be T1 or L1, and let this layer be L2, then if the light is coming from L1 and L2, as they have different optical densities, we can see that the light refracts continuously. And you can see one more thing, that is the optical density at this time continuously changes. It can be become denser medium or rarer medium. As a result, the variation, the refraction process also continuously changes. So this is because the atmosphere contains different particles and the temperature is different and they changes continuously. As a result, the optical densities also changes continuously. At times, we will see that one layer is optically denser, at the next moment it will become optically rarer. Sometimes it will be optically rarer, sometimes it becomes optically denser. So we cannot fix a particular layer that this is optically this much optical, this is an optical denser medium, denser layer, this is an optical rare layer. We cannot say like that. So this is how the atmospheric refraction takes place there, and this is a reason behind atmospheric refraction. Okay, so due to the changing atmospheric refraction, we have three phenomena: twinkling of stars, apparent position of stars, and also early sunrise and delayed sunset. So the first thing is that twinkling of stars. Let us see why this twinkling of stars takes place. Just imagine that there's a star here, okay, and the light is coming from the star like this, and it enters the Earth's atmosphere. And the specialty of Earth's atmosphere is that it is continuously changing due to the change in temperature and all. So as the light enters the atmosphere, what happens is it continuously undergoes a refraction process. So sometimes at this particular moment, the refraction process will be like this. The next moment, this two layers would change its optical densities. As a result, the refraction also changes continuously. So if you're standing here, you can see that due to the atmospheric refraction, or due to the changing atmosphere, the intensities of light changes continuously and it reaches your eyes like this. Okay, so and this give an optical illusion of twinkling of stars. So this gives rise to a feeling that the stars are twinkling. Actually, it's not what twinkling. It is because of the atmospheric refraction or changing in atmosphere. the intensity, the level of refraction will be different at different time. As a result, the intensities which is reaching your eyes is different, and it gives a what feeling of twinkling. So this is how twinkling of stars takes place. And also one more reason is there that we'll study in the coming session, that is apparent position change. Due to this refraction, their position also, that means at this moment, at this moment, the star will be felt like somewhere here, shown somewhere here. At the next moment, due to the refraction change, its position also changes continuously. Position doesn't mean that it's actual position, it's apparent position. Okay. As a result, it gives a feeling that the twinkling keeps on going there. So this is why the twinkling of stars takes place there. And one more thing is that as the star is far distance from Earth, it is considered as a point source. So what happens is the light is coming from a point source. As a result, the apparent position also changes there, as well as we can also see that the intensities are also changing due to the changing atmosphere as well as change in atmospheric refraction. Then one question can come here. So why the planet is not twinkling? In that case, you can see that the planet is situated nearby, and it is not considered as a point source. It's a group of point source. Star is a single commodity, that's a point source. That means the light is coming from a single point source. Whereas in the case of a planet, it is considered as a group of point source. Means point sources are there. So the intensities, even though the intensities are changing, it compensate. All the point sources will compensate against each other, and you will get a correct intensity of light. As a result, the planets won't twinkle, whereas the stars twinkle there. So this is about twinkling of stars. Now the next topic, that is the apparent position of the stars. Just imagine that the star is at the position S1. Okay, here. There's a position, right? Okay. Now what happens is the light from the star comes there and it enters. And again, I'm saying star is considered as a point source. So a single ray is considered as a single intensity of light is coming and reaching your eyes. So it enters the atmosphere and it undergoes what? The refraction process. The refraction process, and it bends, and it reaches your eyes like this. But your eyes have only a special feature that it can see it in a straight line. So it goes on like this. The line goes on like this, and you will see the star like this somewhere here at this position, apparent position A1. The actual position is at S1, but you see the star, the exactly same star at which position? A1. The actual position of star will be somewhere downside. You will see somewhere at a height, a particular height than the original star. And this is known as what? The apparent position. Apparent means the visible position, the apparent position of star. So the stars which we are seeing through our naked eyes is not the actual position of the stars. It is somewhere what different from the apparent position. So we'll see that this is because of what? This is because of the atmospheric refraction. Why? Because due to atmospheric refraction, if the light comes from the stars bends, it bends there and reaches your eyes, and your eyes have a specialty of seeing it in a straight line. So the position will change here. So this is the apparent position of the stars. And if someone is asking you in a question in the board exam, this is very important. So questions already had come, and you can expect this question also. That is, what is the apparent position of star, and explain how the apparent position of stars is seen, is different from the original position of the stars. So I hope that you got the point there. Now the third point, that is early sunrise and delayed sunset. So what is this early sunrise? Or sometimes the question can come as advanced sunrise and delayed sunset. Let us see that particular case. So this is a diagram for the early sunrise and delayed sunset. Just imagine that this is Earth. Okay, this is the Earth there, and you can see this is a horizon part. This small dotted line is a horizon there. So it seems that the sun is coming from the horizon and sets at the horizon. So if you're going for to the beach and all, you can see that thing clearly. Those who had visited Vivekananda rocks and all might have seen that clearly that the sun is coming out of the sea and going inside the sea. Okay, don't think that the sun is dipping into and coming out of the seas. So that is an illusion. Okay, now why this is happening and what happens here actually? So just imagine that the sun is below the horizon. So you can see the sunrise, the sun rays will come out in different directions, in all the directions, and the sun rays starts to come out. Okay. And as soon as it comes out, you can see that as soon as it enters the Earth's atmosphere. So this is Earth's atmosphere. And as soon as the sunlight enters the Earth's atmosphere, it starts atmospheric refraction. And it feels that it bends. It's not feeling, it bends, starts bending. It bends there, bends there, bends there, bends there, like that. And if you are standing here, if you are standing here, and the slowly sun rays will slowly enter your eyes. But your eyes have a specialty of seeing it in a straight line. That means your eyes will see the sun somewhere here, even though the sun is below the horizon. So, what does this mean? This means that even though the sun is below the horizon, that means it haven't risen till now, but still you can see the sun at a different apparent position above the horizon. That means a 2 minutes early, it is from the studies and all, we found out that it's a 2 minutes early. Even though the sun is below the horizon, 2 minutes earlier, you can see the sun has already risen. And it is in the apparent position, and it is due to the atmospheric refraction. The same thing happens for the sunset also. In that case, you can see that the sun, this is a horizon, and the sun will be here. As soon as the sun just gets down the horizon, still the sun rays will go there, go there, go there, and then it bends, undergoes atmospheric refraction, it bends, and you can see that thing in a straight line, and still you can see the sun is in the apparent position above the horizon. So in the second case, you can see that even though the sun has already set, still for 2 minutes you can see the sun above the horizon due to the atmospheric refraction process. So this is known as early sunrise. Why? Because even though the sun is below the horizon, you can see the sun early. That's why it is said that early sunrise. And in the why, what is this delayed sunset? Even though the sun has already set, still you can see the sun there above the horizon for 2 minutes, and that is why it is called as a delayed sunset. Here in both phenomena, you can see that both cases of early sunrise and delayed sunset, it is because of what? Atmospheric refraction process. So all the three phenomena, the first one is twinkling of stars, second one is apparent position, and the third one, that is early sunrise and delayed sunset, it's all because of the atmospheric refraction. And I hope that you got the points clearly. So I hope that you got the points clearly, clear, crisp and clear, and don't make any mistakes for the exams. This is a very important topic. So just stay tuned for more topics of class 10, 11, 9, as well as 12th also we are planning. So it will be coming soon. So we need your support, like you're supporting now by your like, share, comment, and subscription. So please do support. And till we meet again, it's goodbye from the Physi Dive team. Thank you.